Have you been, scrolling through your feed lately and noticed those viral videos that just seem to completely flood every platform back in late 2025 and early 2026?
Oh, the ones with the aggressively capitalized captions.
Yeah, exactly. Those the ones shouting, Finland has eliminating power cables for good, or electricity is now floating through the air like Wi-Fi.
Right, yeah.
The imagery in those clips is just undeniably captivating, isn't it? I mean, you watch someone walk into this completely empty, flawlessly minimalist Scandinavian living room, and they place a lamp on a glass table, and bam, it immediately powers on.
Without a single wire in sight.
Exactly. Not a single wire. Then a sort of futuristic-looking vacuum cleaner begins gliding around the room, panels glowing, and it's apparently drawing high-voltage power from the empty air itself.
It looks like pure magic.
It really does. Unadulterated magic. It sells this intoxicating vision that we've finally stepped into the frictionless science fiction future we've been anticipating for decades.
Well, it is an incredibly seductive image, to be fair. The idea of an entirely unplugged world speaks to a very deep, almost instinctual desire we have for our technology to become seamless and, well, invisible.
Because we're all just exhausted by the physical clutter of the modern world.
Spot on. We absolutely are. But as is so often the case with demonstrations that look indistinguishable from magic on social media, the underlying reality is profoundly more complex and, I would actually argue, far more fascinating than the illusion being sold.
Which is precisely what we're unpacking today, because the reality behind those viral clips is masking a genuine scientific achievement that completely reshapes how we understand localized energy transmission.
It really does.
So for this deep dive, we've gathered a rather extraordinary stack of sources. We are examining recent, highly technical research papers published by Aalto University and the University of Helsinki.
Brilliant papers, by the way.
They really are. And we're integrating that with rigorous fact-checking journalism that deconstructs those viral videos alongside some historical analyses of Nikola Tesla's earliest experiments.
Right.
And to cap it all off, we are delving into the visionary, highly structured writings of an independent researcher based here in the UK, Antonio Víctor Salas Dual.
It's a massively ambitious collection of material, really, because it forces us to bridge this often massive chasm between verifiable, hard laboratory physics and grand socioeconomic philosophy.
Yeah, we're charting a course from the strict parameters of loop antennas all the way up to the architectural blueprints of entirely new societal ecosystems.
Which is quite the leap.
It is. So our mission today is to systematically dismantle that social media hype and isolate the brilliant science actually occurring in Finland. We will examine what these engineers have genuinely achieved with wireless energy transfer.
And crucially, we'll explore why this modern approach is fundamentally different from the global atmospheric power network that Nikola Tesla envisioned over a century ago.
Exactly. And finally, we'll look at how an emerging economic and philosophical framework is planning to utilize this exact grounded technology to construct the ecological communities of tomorrow.
It's going to be a brilliant deep dive.
I'm so excited for it. But before we can appreciate the magnitude of what the Finnish laboratories have accomplished, we really must first understand the prevailing internet narrative and the historical ghost that sort of haunts it.
Because the internet rarely generates these specific technological fantasies in a vacuum. There's always a root.
Right, there's an origin point.
Exactly. The concept of electricity flowing freely through the air has a very distinct origin point, and it is deeply entangled with the legacy of Nikola Tesla.
Always Tesla.
Always. When you look at the claims proliferating across YouTube, X, and LinkedIn, this idea of a groundbreaking system that moves energy across vast spaces safely, rendering traditional power grids obsolete, you are essentially looking at a digital resurrection of Tesla's ultimate ambition.
We're talking about the Wardenclyffe Tower project in the early 20th century, right?
That's the one.
Because Tesla wasn't merely trying to send a Morse code signal across the Atlantic. I mean, his vision was a planetary scale transmission system.
Completely global.
Yeah. He theorized that by utilizing the natural resonances of the Earth and the ionosphere, he could transport massive amounts of usable electrical energy to any location on the globe.
Right.
The dream was that you could, plant a receiving antenna into the soil in a remote Yorkshire field or the middle of the Australian outback and just draw down power from this pulsing global network.
Which is a stunning conceptual leap for the time.
It really is. So considering the absolute brilliance of Tesla's earlier alternating current inventions, why did the Wardenclyffe vision fail so spectacularly? I mean, The popular internet consensus is always that his financiers simply withdrew their capital to protect the copper wire monopoly.
Ah, well, the withdrawal of funding by figures like J.P. Morgan is a historical fact, yes. But the financiers withdrew because the physics of the proposal were entirely insurmountable.
Really?
Oh, absolutely. The historical analyses in our sources are uncompromising on this point. Tesla's dream of a planetary free energy network faced fundamental terminal problems.
Like what?
Well, the most immediate issue was energy control. Think about it. If an installation is pumping megawatts of electrical power into the Earth's crust and the atmosphere, how does the operator direct that energy?
Oh, right. You can't exactly aim it.
Exactly. How do you ensure it is solely received by designated, perhaps paying users rather than discharging indiscriminately everywhere?
That's a massive billing problem, for one.
Quite. But the far more fatal flaw was the sheer scale of energy dissipation. The environmental losses via radiation meant that a global network was scientifically unviable.
You just lose too much along the way.
You cannot inject electrical energy into the open environment without losing the vast majority of it to surrounding space. It just bleeds out.
Let's delve into the mechanics of that dissipation for a second, because the sources repeatedly reference the inverse cube law regarding magnetic dipoles in the near field.
Yes, that's the absolute core of the issue.
Right. And for someone listening who follows technological developments but doesn't necessarily hold a degree in electromagnetics, how should we conceptualize the brutality of that decay?
Well, to understand the inverse cube law, we have to distinguish between the near field and the far field.
Okay.
So when a radio station broadcasts, it uses electromagnetic radiation in the far field. That energy detaches from the antenna and travels outward, and its intensity diminishes according to the inverse square law.
Which is fairly standard.
Right. But when we are talking about wireless power transfer using magnetic fields, which is what is strictly required to actually run a device rather than just, send a faint data signal to a radio, we are operating in the near field.
And the near field behaves differently.
Drastically differently. In the near field of a magnetic dipole, the field strength decays according to the inverse cube law.
Which means what exactly?
This means that if you double the distance between the power source and the receiver, the energy doesn't drop by half or even by a quarter. It drops by a factor of 8.
Oh, wow. A factor of 8? Just by doubling the distance?
Exactly. And if you increase the distance tenfold, the available energy drops by a factor of 1,000.
That is it's an astronomical rate of decay.
It essentially hits a wall.
So, relying on the near field for power transmission means you are fighting a law of physics that aggressively punishes distance.
Massively punishes it, yes.
So if I want to power my television from a transmitter at the other end of the room, the source would have to generate such a colossal, catastrophic amount of energy just to overcome that inverse cube decay. I mean, the space between the transmitter and the receiver would become incredibly hazardous, wouldn't it?
Hazardous and absurdly wasteful. You would be pouring an absolute ocean of energy into the room just to deliver a tiny drop to the television.
Right.
This is the ultimate physical limitation that defeated Tesla's atmospheric ambitions, and frankly, it remains an absolute law of physics today.
Which brings us to a really unavoidable contradiction. Well, if the physics explicitly dictate that near-field magnetic power decays at such an aggressive rate, what on earth are we witnessing in those viral videos?
Ah.
I mean, if a room cannot be flooded with atmospheric electricity safely or efficiently, how are these content creators achieving the visual effect of an entirely wireless-powered room?
Well, the fact-checking sources we were reviewing break this down quite systematically. The viral videos are essentially sophisticated optical illusions.
I knew it.
Yeah, they conflate multiple distinct and highly limited technologies to fabricate a totally false narrative.
So they're taking a tiny bit of truth and blowing it out of proportion.
Exactly. They take a sliver of truth, like the actual results from the Finnish laboratories, which we will discuss shortly, and merge it with completely unrelated phenomena.
Like what kind of phenomena?
For example, some of the more dramatic visuals, where energy appears to leap across a room to power a device, are often demonstrations of guided sparks using plasma physics or ultrasonic acoustic energy.
Oh, so it's not even standard electricity transmission.
No, not at all. They are fascinating physical phenomena, absolutely, but they are completely useless for running household appliances.
Because they don't carry enough power.
Right. They carry almost no usable current and are highly unstable.
So they are essentially high-voltage parlor tricks designed for maximum visual impact on a camera sensor.
That is spot on. Furthermore, many of the videos that show devices charging seemingly anywhere in a space are filmed inside highly specialized resonating chambers.
Wait, what does that mean? Resonating chambers.
These are rooms constructed entirely from solid aluminum plates, engineered to function as giant resonant cavities.
Oh, wow.
Yes. If you build a hermetically sealed metal box, you can bounce electromagnetic waves around inside it to charge a device anywhere within that volume.
But that's an entirely impractical architecture for a human living.
Exactly. You cannot construct residential homes as solid aluminum Faraday cages.
No, you'd never get a mobile phone signal, for one.
Quite. So the Internet Hype Machine has essentially taken the rigorous centimeter-scale engineering occurring in actual laboratories, stripped away all the necessary context regarding distance and safety, and packaged it within the ghost of Tesla's impossible planetary grid.
It's incredibly deceptive. But having cleared away the debris of that viral illusion, we can now examine the verifiable reality.
And the reality is brilliant.
It really is, because the actual breakthrough achieved by the Finnish researchers, specifically the teams at Aalto University, is an absolute masterclass in precision engineering.
The word precision is vital here.
Right, because it operates on a much smaller scale than the internet claims, but it still represents a profound leap in the field of electromagnetics.
Absolutely. The Aalto University researchers are not attempting to conquer the atmosphere. They're attempting to conquer the immediate spatial gap between devices with unprecedented efficiency.
Let's lay out the precise parameters of the Aalto University achievement, just so everyone is clear.
Go for it.
So they have developed a system for high-efficiency wireless power transfer at a medium distance, utilizing loop antennas.
Right.
And the crucial data points from the papers are these. They successfully maintained over 80% energy transfer efficiency across a physical gap of 18 centimeters. That's about 7 inches.
Yep.
And they achieved this using 2 circular loop antennas that are merely 7.2 centimeters, or roughly 2.8 inches in diameter.
Now, to a layperson, 18 centimeters might sound utterly trivial.
Right. It is roughly the span of a human hand.
Exactly. But in the context of near-field electromagnetic engineering, that distance relative to the size of the antennas is a monumental canyon to cross while retaining 80% of your power.
It's massive.
Consider the standard inductive charger you might have on your desk for your smartphone.
Oh, those require the phone to be in direct physical contact with the pad.
Exactly.
If I lift the phone even half a centimeter, the charging icon instantly disappears.
Because classical inductive coupling relies on the magnetic fields being tightly bound between 2 coils that are practically touching.
Right.
The efficiency degrades instantly the moment you introduce spatial separation or lateral misalignment. The Aalto team has managed to maintain extreme efficiency across a gap that is roughly 2.5 times the diameter of the antennas themselves.
Which is incredible.
Bridging that proportional distance without the energy succumbing to the devastating effects of the inverse cube law is an astonishing feat of applied physics.
I am really trying to reconcile this with the aggressive decay we just discussed, though.
It is tricky, yes.
If the inverse cube law mandates that the magnetic field strength drops off a cliff as it moves away from the source coil, how on earth are the Aalto engineers maintaining an 80% transfer rate across an 18-centimeter void?
Wow.
Doesn't the energy naturally want to dissipate into the surrounding environment?
It does naturally want to dissipate, which is why the Aalto researchers had to introduce a highly advanced conceptual framework called radiation suppression.
Radiation suppression.
They developed a dynamic mathematical theory to actively prevent the energy from leaking into free space as electromagnetic radiation.
How do they do that?
The mechanism relies on meticulously controlling the electrical currents within both the transmitting loop and the receiving loop. They engineered the system so that the currents in both antennas operate with the exact same amplitude, so the same magnitude of force, but they're forced into opposite phases.
Wait, let me test my understanding of phase cancellation here.
Please do.
If we look at acoustics, active noise-canceling headphones work by listening to the ambient sound waves in the environment, right?
Yes.
And then they instantaneously generate a sound wave that is the exact mirror image, the opposite phase.
Spot on.
So when the peak of the ambient wave meets the trough of the generated wave, they effectively cancel each other out, leaving silence. Are the Aalto engineers applying a similar principle to magnetic fields?
That is an exceptionally strong parallel, actually. In acoustics, you are canceling pressure waves in the air. In this wireless power system, they are dealing with coupled electromagnetic resonators.
Right.
By ensuring the currents in the transmitting and receiving loops are in strict phase opposition, the electromagnetic fields generated by the two coils interact in a way that suppresses the radiation resistance.
So they block it from spreading.
The fields essentially destructively interfere with each other in the far field, meaning the energy cannot radiate away into the room.
Wow.
Because the energy is blocked from escaping outward, it is forced to couple mutually between the two loops. It is as if they have constructed an invisible, tightly sealed tunnel between the two antennas, preventing any energy from bleeding out the sides.
Wait, but if they are actively canceling the radiation, where does the excess energy go? I mean, if the fields are destructively interfering, doesn't that imply the energy is just being destroyed, which would, violate conservation laws?
A very perceptive question. No, it does not violate conservation laws because the energy is not destroyed. It remains as reactive near-field energy.
Reactive energy.
Yes. In electromagnetics, real power is the energy that radiates away and is permanently lost to the environment. Reactive power is the energy that oscillates back and forth between the source and the surrounding field without being dissipated.
Oh, I see.
So by suppressing the radiation, they are preventing the conversion of this energy into real lost power. The energy remains trapped in the reactive near field, bouncing between the two coupled coils until it is absorbed by the receiving antenna and converted back into direct current.
It is an incredibly elegant manipulation of field dynamics.
It's beautiful, really.
But this level of finesse requires us to look under the hood. To truly appreciate the sophistication here, we need to move beyond the theory and examine the physical architecture of the system.
Absolutely.
The sources detail a 5-block functional architecture that makes this Aalto system operational.
And the architecture is best understood as a continuous, intelligent signal path.
Okay, let's walk through it.
The first functional block is the power supply. The system takes standard direct current power and runs it through a high-frequency inverter, converting it into an alternating radio frequency signal that oscillates in the hundreds of megahertz.
So we are taking raw power and turning it into a high-frequency wave.
Exactly.
Once we have that high-frequency RS signal, we reach the second block, which is the transmitting loop antenna.
Right.
And this component takes that oscillating current and generates the intense, localized magnetic field.
Which then brings us across the physical gap to the third block, the receiving loop antenna.
Where the magic happens.
Exactly. This is where the critical phase matching occurs. The receiving loop is geometrically identical to the transmitter, and it captures the oscillating magnetic field. Because the system is tuned to maintain that opposite phase relationship, the radiation suppression effect locks the energy transfer in place.
But at this stage in the architecture, the receiver has captured a high-frequency radio frequency signal.
Yeah.
And consumer electronics and industrial batteries do not run on radio waves.
Yeah.
They require stable direct current. I imagine the rectification process at these high frequencies must be a significant engineering bottleneck.
It's a massive challenge. And this is the fourth block, the adaptation and rectification network.
Right.
Converting an RF signal in the hundreds of megahertz back into usable DC power typically incurs severe efficiency losses. High-frequency diodes and rectifiers generate heat and lose power during the conversion.
Which ruins the whole point of an efficient system.
Exactly. The fact that the Aalto team achieved over 80% end-to-end efficiency means their rectification network is performing at the absolute bleeding edge of current materials science.
That's incredible.
They are capturing the wave and flattening it back into a stable DC line with minimal thermal loss.
Which leads to the final and arguably the most revolutionary functional block, the control and feedback channel.
Yes, the brains of the operation.
The sources indicate that this system is not static. It incorporates sensors that continuously monitor the coupling efficiency.
And this is what elevates the technology from a laboratory curiosity to a viable real-world infrastructure.
Because the real world is messy.
Exactly. The environment is never static. Devices move, temperatures change, foreign objects pass through the field. The control and feedback channel dynamically adjusts the frequency, the phase relationship, and the power levels in real time.
So if it shifts,
if the receiving device is moved a centimeter to the left, the system senses the drop in coupling efficiency and instantaneously recalibrates the phase to maintain the optimal radiation suppression tunnel.
that dynamic adaptability is what makes this so vastly superior to the brute force methods we see in other research.
Absolutely.
I mean, the sources draw a sharp contrast between Aalto's approach and the charging rooms being developed by institutions like Disney Research and the University of Tokyo.
The contrast is illuminating, really, because it highlights two completely divergent engineering philosophies.
How so?
Well, the Disney and Tokyo projects rely on a phenomenon known as quasi-static cavity resonance.
Oh, that sounds intense.
To implement this, you must physically enclose a space, say, a standard 3 by 3 meter room, with highly conductive aluminum walls, floor, and ceiling.
Right, the metal boxes you mentioned earlier.
Yes. You then stimulate the resonant electromagnetic modes of that entire enclosure. The walls themselves become part of the circuit, reflecting the waves inward so that a device placed anywhere in the volume can draw power.
It sounds incredibly intrusive. You are essentially turning a living space into a life-sized microwave oven interior.
Intrusive and highly inflexible. You cannot easily install windows, you cannot change the dimensions of the room without entirely recalculating the resonant frequencies, and while you're subjecting the occupants to a constantly pervasive electromagnetic field.
Which just feels wrong.
It does. The Aalto methodology abandons the need for a resonant cavity entirely. It relies on highly optimized open-air coupling between two specific points.
It's targeted.
Highly targeted. It builds a temporary invisible bridge exactly where it is needed, and when the device is removed, the field collapses.
And because of that active control loop, it enables dynamic charging. We are no longer discussing a phone sitting statically on a desk. We are talking about delivering power to objects that are in constant motion, tracking them, and adjusting the magnetic coupling on the fly.
And when you introduce spatial adaptability like that, the commercial applications expand exponentially.
Which naturally brings us to the question of implementation, scale, and safety.
Right.
If we possess this hyper-efficient, adaptable wireless power system, the immediate question from you, the listener, is going to be, why isn't it installed in my home today? Why am I still wrestling with power cables behind my television?
The delay in widespread consumer rollout is dictated entirely by strict international safety boundaries and the physiological effects of magnetic fields.
Safety first, as always.
Always. While the Aalto system is incredibly efficient, generating the intense magnetic fields required to transfer high wattage through the open air carries significant biological implications.
The sources specifically cite the ICNIRP guidelines, the International Commission on Non-Ionizing Radiation Protection. How do these regulations restrict the application of this technology?
The ICNIRP guidelines establish strict thresholds for human exposure to electromagnetic fields to prevent tissue heating and nerve stimulation.
Tissue heating, that sounds bad.
It is. High-intensity magnetic fields can induce electrical currents within the human body. At lower levels, this might be imperceptible, but at higher wattages, it can interfere with critical medical devices like pacemakers and cause the localized heating of biological tissue.
Oh, wow.
You simply cannot pump kilowatts of energy across a living room if a human being might casually walk through the transmission corridor. The safety limits impose a strict ceiling on the power output in unregulated civilian spaces.
This perfectly explains why the immediate applications detailed in the research are located at two extreme ends of the spectrum: ultra-low power in the human body, or high power in environments completely isolated from human presence. Let's look at the ultra-low power applications first. The sources highlight parallel research occurring at the University of Helsinki regarding biomedical implants.
This is perhaps the most elegant near-term application. The researchers at Helsinki are developing miniaturized loop antennas based on these exact same principles for small brain implants and neural stimulators.
In the brain.
Yes. In a biomedical context, the distances involved are tiny, merely transmitting through the skull and a few layers of dermal tissue.
And crucially, the power requirements for a neural sensor are in the milliwatt range.
Exactly. Because the power demand is so incredibly low, the generated magnetic fields are infinitesimal, falling well below the strictest ICNIRP safety thresholds.
So it's completely safe.
Absolutely. The immense benefit here is the elimination of percutaneous wires that physically breach the skin.
Oh, right, because those are an infection risk.
Any wire passing through the skin creates a permanent vector for severe infection. By utilizing high-efficiency wireless transfer, the implant is entirely sealed within the body, operating indefinitely without the need for invasive battery replacement surgeries.
That is just brilliant. But moving to the opposite extreme, the Aalto researchers are scaling the technology up for heavy industry. specifically targeting commercial warehouse robotics.
And the logistics and warehousing sector is desperate for this innovation.
I can imagine.
Currently, automated guided vehicles and warehouse robots operate on a very inefficient duty cycle. They work until their battery depletes, at which point they must navigate away from the active floor, dock with a physical charging station, and remain totally idle while they recharge.
Which is dead time.
Exactly. Furthermore, physical electrical contacts in heavy industrial environments degrade rapidly due to dust, mechanical wear, and misalignment.
The Aalto teams are currently testing the loop antenna systems on these robots at a transfer rate of 1 kilowatt, right? And with explicit plans outlined in the sources to scale the architecture up to 20 kilowatts.
At 20 kilowatts, we are discussing serious industrial power. The implementation model here relies on dynamic on-the-move charging.
How does that work in practice?
Instead of a robot parking at a station, specific high-traffic corridors within the warehouse are equipped with transmitting loops. As the robot drives through these specific zones, the control and feedback network engages, matches the phase, and floods the robot's receiving antenna with power.
So it charges while it's driving.
The robot recharges continuously while it works. No downtime.
And safety is maintained because these specific charging corridors can be geofenced. Human workers are physically excluded from the zones where the high-intensity magnetic fields are active.
Exactly. The geometry of the space is heavily controlled to ensure compliance with human exposure limits.
This provides a crucial reality check. When the internet claims that Finland is preparing to power entire cities wirelessly, the truth is that the genuine science is confined to the centimeter and meter scale. It is surgical, high-efficiency power designed for highly regulated environments, whether that is the interior of the human skull or the cordoned-off floor of an automated warehouse. It is a masterpiece of targeted engineering, not a magic wand for the civilian power grid.
It is the difference between a sniper rifle and a hand grenade, really. The Aalto system is precision engineered for specific, bounded spatial applications.
We have thoroughly established the strict physical parameters of this technology. We understand the limits of the inverse cube law, the brilliance of radiation suppression, and the hard safety boundaries dictated by human physiology.
We have.
But here is where our exploration takes a profound, almost jarring pivot. Because while the physics rigidly constrain the distance this technology can bridge, the conceptual implications of invisible, decentralized power are inspiring a completely radical rethinking of human societal structure.
We are moving from the laboratory bench to the philosophical drawing board.
We really are. We are transitioning into the domain of Antonio Víctor Salas Dual. He is a fascinating figure to encounter in this context because he operates across disciplines that are usually fiercely segregated.
Extremely segregated, yes.
He is based in the UK with a background in IT and independent research, but his work encompasses profound numerical theory and highly ambitious sociopolitical design.
Let's begin with his theoretical work, because it sets the foundation. The sources identify Salas Dual as the discoverer of a conceptual framework he has termed the Tesla matrix.
Right.
Now, the documentation explicitly restricts us from delving into the deep mathematical mechanics of his discovery, but we need to explain what this actually represents.
Because when the average person hears the word vibration, coupled with the name Tesla, they immediately assume we are drifting into the realm of pseudoscience or New Age mysticism.
It is a vital distinction to make. Salas Dual is not using vibration in a mystical sense at all. He is employing it as a Tesla-inspired conceptual label to describe numerical signatures within a hidden architecture.
So it's a structural thing.
Completely. The Tesla matrix, as he presents it, is a profound structural framework. You can conceptualize it as an underlying coordinate system for numbers themselves. It suggests a hidden rhythm or an ordered architecture that governs numerical relationships.
It is a classification system, essentially. He has observed a structural order and given it a nomenclature based on vibrational resonance.
Correct. It is a way of understanding the foundational structures of reality. But what makes Salas Dual's work so compelling is that he did not simply publish this theoretical matrix and stop there.
He applied it.
He took the implications of this underlying ordered structure and applied it to macro-human organization. He is the creator and architect of a project called Etherbios, or Eterbios in its Spanish conception.
Now, when I first encountered the term Etherbios in the sources, I assumed it was, a clean energy startup pitching a new hardware integration.
Many people do.
But the scope of Etherbios is staggering. The texts define it as an upcoming economic, political, and philosophical spiritual ecosystem. It is an entirely holistic model for human civilization.
It represents a complete paradigm shift in how we structure communities.
And we should mention the sources are very clear that this is politically neutral, right?
Oh, entirely neutral. The documentation emphasizes that the Etherbios concept does not align with contemporary left-wing or right-wing political parties.
Which is quite rare.
It is. Nor does it rely on traditional growth-obsessed capitalism or standard state plan socialism. It proposes an entirely novel way for human communities to organize their labor, manage their resources, and interface with the natural environment.
And we're just reporting what's in the text here. But the stated objectives of an Etherbios colony are total ecological self-sufficiency and profound societal harmony.
Yes. What I find so striking is the classical nature of this approach.
How do you mean?
Well, in the modern era, we hyper-specialize. The electrical engineers stay in the lab, the sociologists study group dynamics, and the urban planners draw zoning maps. They never talk to each other.
Right, everyone in their own silo.
Exactly. But Salas Dual is bridging deep numerical structure, the Tesla matrix, directly with grand socio-political architecture. He is treating technology not merely as a commercial product to be sold, but as the foundational mortar for a new human ecosystem.
It strongly echoes the holistic thinking of the Renaissance, where mathematics, physical engineering, and moral philosophy were viewed as one continuous tapestry.
Spot on.
The underlying premise seems to be that if you can understand the true structural architecture of reality, the matrix, the vibrations, you can design a society that operates in fluid harmony with those laws, rather than constantly fighting against them in a state of friction and extraction.
Which brings us to the absolute crucial intersection of our deep dive.
Yes.
How does the hyper-efficient, highly restricted wireless technology developed in Finnish laboratories fit into the grand, holistic vision of an Etherbios colony?
Right, because if Etherbios aims for total self-sufficiency, how do they overcome the physical limitations of the technology we just spent an hour deconstructing?
Well, they overcome the limitations by respecting them entirely. In the architectural vision for future Etherbios colonies, the energy infrastructure is ruthlessly pragmatic. They are not invoking the ghost of Wardenclyffe.
They aren't trying to beam power globally.
No. These communities will rely on proven, heavy-lifting renewable technologies to generate their baseline power. The quantitative generation will be handled by expansive solar arrays, advanced wind turbines, and potentially geothermal systems.
So the generation occurs on the macro scale, completely external to the living spaces.
Exactly.
But the critical challenge of any self-sufficient community is distribution. How does the power move from the solar farm to the medical clinic or the agricultural robotics? This is where the Finnish technology is deployed, isn't it?
Yes. It handles what we might call the last meters of distribution.
The last meters. I like that framing.
Think about the historical evolution of the internet.
Okay.
The global internet relies on massive, heavy infrastructure, thousands of miles of undersea fiber optic cables, and football field-sized server farms consuming gigawatts of power.
Right. Highly physical and highly intrusive.
But in the final few meters, within the walls of your home or office, Wi-Fi liberates you from the physical connection. You do not drag an Ethernet cable from room to room anymore.
The heavy infrastructure is hidden, and the user experience is entirely wireless and frictionless.
Precisely. In the Etherbios model, the Aalto wireless technology performs this exact function for clean energy. It manages the local distribution.
And they use it for the final leg.
The community utilizes the Finnish tech to create highly controlled geometric islands of wireless power.
Islands of power.
Yes. These islands distribute the locally generated renewable energy to internal transport systems, automated environmental sensors, and throughout community workspaces, entirely eliminating the physical clutter and maintenance burden of copper wiring.
It is a brilliant integration because it perfectly matches the scientific boundaries we discussed earlier.
It does.
The Finnish loop antennas are designed for short, highly controlled distances using phase cancellation and radiation suppression. Rather, BIOS doesn't attempt to break physics and beam power across a valley. It embeds these transmission loops into the physical architecture of the communal zones.
It is a system that acknowledges the inverse cube law, acknowledges the ICNIRP safety limits, and designs the living environment around those hard realities.
It is the elegant application of physics to enhance human harmony. By removing the physical tether of the power cable, Etherbios transforms the concept of ecological self-sufficiency from a dry, technical spreadsheet regarding carbon offsets into a lived, daily psychological experience.
That's beautifully put. It really makes you reflect deeply on the legacy of Nikola Tesla that we discussed at the very beginning.
It really does. We started by dismantling the myth of his planetary grid, acknowledging that his specific engineering vision was fundamentally flawed and physically impossible.
Right.
But when you examine the Etherbios ecosystem, you realize that while Tesla's physics failed, his philosophical ambition has survived.
The ambition for an environment where energy is abundant, invisible, and seamlessly integrated into the human experience.
Exactly. Etherbios captures the purest spirit of Tesla's dream. It envisions an environment where energy flows quietly to where it is needed, without scarring the landscape with pylons or cluttering the home with cables.
A space where science, community, and the natural environment operate in a state of frictionless balance.
It is a profound synthesis. It demonstrates that true innovation does not require breaking the laws of physics. It requires mastering them with such extreme precision that the resulting technology fades into the background, leaving only the human experience.
Hear, hear.
We have traversed an immense amount of ground today. We began by confronting the viral social media illusions, the seductive but scientifically vacant promise of free atmospheric electricity.
The magic tricks.
The magic tricks. We systematically stripped away that hype to reveal the rigorous, mathematically beautiful physics occurring at Aalto University and the University of Helsinki.
We explored the mechanisms of loop antennas, the brilliance of radiation suppression through phase cancellation, and the astonishing engineering required to bridge an 18-centimeter void with 80% efficiency.
We also established the unforgiving boundaries of that reality, acknowledging the physiological limits of magnetic field exposure and how they dictate the real-world applications, from milliwatt brain implants to 20-kilowatt automated warehouse logistics.
And finally, we zoomed out from the microscopic scale of electrical currents to the macro scale of human civilization, exploring how Víctor Salas Dual's Etherbios project plans to use this exact, limited technology as the invisible nervous system for a totally new, self-sufficient societal architecture.
It really is a journey from the limits of physics to the boundaries of philosophy. I want to leave you, the listener, with a final provocation to consider as you move through your environment today. For over a century, our civilization has been utterly defined by the grid. We have blanketed the Earth with massive, sprawling, highly vulnerable cables that tie us to centralized power stations located hundreds of miles away.
It is an architecture of dependency and physical intrusion.
But if the rigorous researchers in Finland and the holistic visionaries behind Etherbios are correct, the future of energy is not about constructing a larger, more complex grid. The future is about actively dismantling the grid within the intimate spaces where we actually live and work.
Which is a beautiful thought.
Imagine walking into a room that simply anticipates you, an environment that feels alive and supportive, where the devices you rely on are powered invisibly by the wind and solar capture occurring just outside the walls.
A totally different way of living.
If the final few meters of our energy distribution become completely invisible, how profoundly will that alter our psychological relationship with the spaces we inhabit? I invite you to look around your current location. Look at the power cables snaking across your floor, the heavy plugs dominating the wall sockets, the tangled massive chargers on your desk.
It's quite a mess when you really look at it.
It is. And imagine the sheer aesthetic and spiritual relief of a truly unplugged existence. Because the deepest, most permanent technological revolutions almost never look like flashy magic. Ultimately, they just look beautifully, perfectly invisible.